Hello, everyone. Thank you for joining this session. This talk is going to be about Kubernetes Security 101, best practice to secure your cluster. My name is Magno Logan. I'm part of the DS labs here at Trend Micro. So let's start with just a bit of overview about myself. As I said, my name is Magno Logan. Here's my handle on Twitter, GitHub, LinkedIn, everywhere. I'm an information security specialist at Trend Micro and a senior threat researcher. I'm a member of the cloud and container security research team. I'm not a Kubernetes security expert yet, but I'm getting there. And I'm going to take the Kubernetes administration certification soon. So the agenda for today, it's basically give you guys an overview of what is Kubernetes, how it works, what is the Kubernetes architecture, the different components that we have there in your cluster and how they communicate with each other, right? Then we're gonna go about some best practices, talking about the control plane, which is the main node there, the master node, talking a few components, the API server and the etcd. Then we're gonna go into RBack, which is the role-based access control. Then worker nodes, talking about Cubelet, prop odds, and some security features that are available there for you. Then we're gonna mention network policies and why they're important. Pod security policies as well as another way of securing all the pods on your cluster. And lastly, but not least, we're going to talk about audit logs and why they're important for you to have visibility and just best, better security on what's happening, right, on your cluster. So to start off, basically an introduction to Kubernetes if you've never used it before, right? So Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications, right? So if you're running containers, if you're using Docker images, for example, you're running containers, but that's hard to scale, right? So when you have multiple different images and different containers, it's hard to orchestrate and manage that. So Kubernetes is a solution that was created basically to solve that problem, right? So it was originally developed by Google and based on some internal projects called Borg and Omega. It was released in 2014 and it's developed in Go, right? So the Go programming language. And today Kubernetes is maintained by the CNCF, was donated by Google. So the CNCF is the Cloud Native Computing Foundation, which is a sub-foundation of the Linux Foundation. And basically it manages a lot of open source projects and help them grow and scale. So just a fun fact here, Kubernetes comes from the Greek word, which means helmsman or pilot. And in this case, it's an analogy to the captain of the ship that takes the containers, which are the Docker, right? So maybe you don't need Kubernetes. So that's one of the first questions that you should ask yourself and your organization. Why do you need Kubernetes, right? Kubernetes is a complex system and it's hard to understand at first. It's easy to make mistakes if you're not following the best practice, right? So it offers a great deal of flexibility with many configuration options, but at the same time, these configuration options should be understood properly and set in a secure manner, or otherwise you might let your cluster vulnerable and open to attackers, right? There are other solutions that are out there for orchestrating containerized applications. Some of them are Apache Mesos, Docker Swarm, and Red Hat OpenShift. Maybe those other options might be better for your scenario, so you should look into that as well. So I mentioned the CNCF earlier, right? So what is the CNCF? As I said, it's the Cloud Native Computing Foundation. It's a foundation that creates a sustainable ecosystem and promotes communities to support the growth and the health of cloud's open source software, right? So as I said, it's a sub-foundation of the Linux Foundation, and many open source projects are like promoted and hosted and incubated by the cloud native. As you can see, there are many projects there. Kubernetes is just one of them, but Prometheus is very famous as well. Helm, which is a package managed for Kubernetes project, etcd, and etc. So there are a lot of great projects there. And when we're talking about cloud native, what does it mean, right? So sometimes it's hard to understand the concept. What does it mean to have a cloud native application or develop a cloud native application, right? So according to the CNCF, they define that cloud native applications need to have at least these 7 characteristics on the left side. So they need to be scalable, they need to be dynamic, resilient, loosely coupled, as in like microservices, manageable, observable, and automated, right? So with those 7 characteristics, you have some examples of those cloud native applications on the right side, which are containers, service meshes, microservices, immutable infrastructure, and declarative APIs. So basically that's the ecosystem that's composed of cloud native applications, right? Okay, now digging into the Kubernetes architecture here. We have basically 2 different types of nodes on Kubernetes. We have the master node and the worker nodes. You can have multiple sets of them, like I can have a cluster of master nodes and a cluster of worker nodes, right? So, but you need at least, usually you can have just one node, but it's not recommended to run everything on the master node and everything in all your applications on the same node, right? So basically you have that structure on a high level. So on the master node here, we have 5 main components. There are the Kube API server in the middle there, which is responsible for exposing and receiving all the API calls, right? You have the etcd, which is the database where Kubernetes stores all the internal information and all the configurations. It's like what nodes are part of the cluster, what resources are available in the cluster, stuff like that. You have the Kube controller manager, right? So which is responsible for many internal tasks, like noticing when a node is not responding, maintaining the correct number of pods that is required for a specific application, stuff like that. And you have the Kube scheduler, which is the scheduler that decides where to execute the pods. So which node which pod is going to go into, right? And we're gonna go into the pods definition itself on the next line. And you have the cloud controller manager that interacts with the cloud providers, managing resources such as load balancers and disk volumes, right? So this is the master node. It's also known as the control plane. And on the worker nodes, you have at least three main components, which are the kubelet, which is the agent that's responsible for managing the container runtime, executing the containers when necessary, and collecting information about execution, like telemetry data. You have the Kube proxy, which manages the communication, network communication, allowing that different containers can communicate with each other, and also responsible for external requests, right? And lastly, here we have the container runtime, which is the engine that creates and executes the containers requested by the kubelet, right? By default, the container runtime for Kubernetes is Docker, but you could use other container runtime engines such as Containerd or Cryo. Okay, so this is a high level of the Kubernetes architecture. And next, we're gonna see a little bit about the objects and some components that can be created inside your cluster. So here we have the cluster, nodes, pods, and namespaces, right? As I said, the pod is an object inside the Kubernetes cluster, It's the smallest unit that you can have in your cluster. A pod is comprised of at least one or more containers. So it's not a one-to-one relationship. It's not one container is one pod has one container only. You can have that, but you can have more, right? So you can have like a sidecar container collecting log data from that other container, and you can have even more. So it doesn't matter, but a pod is the smallest unit that you can have on Kubernetes, right? You cannot create a container without a pod. So here is just an inside, actually the pods are created, either you can create a pod itself, but usually on a production level, a cluster, you usually want to create a deployment, which is an object inside Kubernetes that creates the pods and manage themselves, manage like scaling updates and rollbacks. So if you need another Docker, another pod of that same image, that you can just edit the deployment there, and the Kubernetes will take care of itself. And also on top of the deployment, you have logical separations inside the cluster, which are the namespaces, which is basically like folders that you have for each project on your cluster. You can separate them into like dev, QA, and production. So there's just a logical separation. It's not a security boundary or anything. And on top of that, you have the nodes, which are the virtual machines or the bare metal servers that you have running on your cluster, right? So some of the objects that that are available for you on Kubernetes are here, the API objects. So I said we have the pod, we have deployments, we also have replica set, daemon set, services, and jobs and cron jobs. So each one of those objects have a special characteristic and a special usage for them, right? We're not going to go into each one of those here on this talk because we don't have time. But basically, it's as you can see, it's a YAML manifest here on the right. It's basically a manifest that you can tell the API server to create that object on a specific namespace that you want, and it's going to create that for you, right? So they are like persistent entities in the Kubernetes system, right? And they use Kubernetes use these entities to represent the state of your cluster. And so how do you communicate with Kubernetes? How do you manage your cluster, right? So Kubernetes has a CLI tool that allows you to control Kubernetes. It's a config, it's the kubectl or kubectl or kube control. I'm not going to go into the discussions of the definition here. Some people prefer one name or the other, but I like to call kubectl. How do you access that? So there's a config file that's inside your home directory, inside the .kube folder, right? And has the certificates and the keys that you need to access your cluster, right? So it's very similar to the Docker CLI tool for Docker containers. So if you have experience managing Docker containers and has worked with the Docker CLI before, so you're not gonna have a lot of trouble. It's gonna be easy for you. The syntax is very similar too, so it's easy to understand. Now going to the best practice here, right? So talking about the master node, or as also known as the control plane, right? So one of the basic things that you can do to secure your control plane is to perform integrity monitoring, right? For the most critical Kubernetes files, right? So if you have access to the control plane, right? So if you're not running your cluster on a managed services like EKS or GKE, you can do this by monitoring their services and being alerted immediately if any changes happen on them, right? So according to the CIS Kubernetes benchmark version 1.5.1 was released a few months ago, I think. There is some critical files on your master node that are important for you to manage and to monitor for their ownership and permissions, right? So those files are listed there in the slides. And so if anything happens to them, if anything, any permissions or ownership changes, you should be alerted about that because something might be going on your cluster. So when you create a cluster using some tool like Kube ADM tool, which is the most common one, you already have 4 namespaces created for you, right? So we mentioned that namespaces are like logical separations between your Kubernetes objects and your cluster. Excuse me. So by default, you have 4 namespaces created for you. You have the default namespace, the kube node lease, the kube public, and the kube system. The most important one here is the kube system namespace, which is the objects that are created by the Kubernetes system are located there. So the objects that we mentioned on the architecture slide on the master node are all located there. So Kubernetes uses Kubernetes to host itself, to maintain itself. So the etcd, the API server, they're all pods inside your Kubernetes cluster. And that's a very important thing to know, because if someone has access to those pods or has access to that namespace, they can basically compromise all your cluster, right? So those other namespaces are just by default there. If you don't have, if you create objects and you don't specify a namespace, they'll be created on the default namespace. And that's about it for this, for the namespaces here. For the Kube API server, right? So we mentioned that the API server is one of the main components on the master node, and you have to be very careful about not exposing your API server to the internet, right? Because if you expose it, then anyone can access it and might be able to issue requests to the API server if they have the proper permissions, right? So as I said, the API server is exposed to receive API calls, not just from the internal components on the master node, but from the kubelet and the worker node components as well. But there are still organizations that make this mistake of leaving the Kube API servers exposed publicly to the internet, right? So it's the most common entry point for attackers, the same way as exposing the Docker daemon API. So that's a very serious issue that you should not do, right? So here you can just issue a curl command to your API server address on the port 6443, which is the default secure port, right? It had in a previous version, it had also an insecure port open by default, but not anymore. And one other thing to notice here is that if you're using the AWS EKS clusters to run your Kubernetes workloads, then that Kube API server endpoint is exposed publicly to the internet, right? So that's something that you need to be very careful about. And make sure that you can use like security groups or VPN access to block public access to that endpoint. So still talking about the API server, right? So there are many settings that are enabled there once you start your cluster. How do you know which settings are enabled? You can issue this command here, ps-ef pipe grep Kube API server on your master node if you have access to it, and you're gonna see all the flags that are enabled on the Kube API server process, right? So according to the CIS Kubernetes benchmark, it has 35 security settings that are recommended for the API server. But as of version 1.18.5 of Kubernetes installed via Kube ADM, only half of those security settings are enabled by default. So the other half is not enabled on your cluster. And you should definitely look into that to see if you need those settings enabled as well, right? So be very careful about that and make sure you harden your Kube API server before you expose it you put it in production, right? As for the RBack or role-based access control, so this is a control that's commonly used on web applications, right? It's controlled access control by roles. So you have like a regular user, you have like a manager, admin, or something like that. Most of the web applications are using this type of access control. Excuse me. So it allows on Kubernetes, it allows you to configure who can access what in your cluster, right? So right now it's enabled by default on the latest Kubernetes version. You can see that from this flag authorization mode RBack, even on the previous slide, you can see that there on the image, right? So how do I check if my cluster has its enabled? It's the same command that we showed before for the Kube API server, right? So the RBack is going to allow you to configure who can access what in your cluster, right? So we highly recommend, if you don't have that enabled, if you're using previous versions of Kubernetes, that you enable that for the RBack authorization. And you can also restrict any user from accessing the kube system namespace, like we mentioned, which is a very important namespace, where all the control plane pods are located, right? So on RBack here, we have at least 4 different objects that can be created. The first object here is the role, which is this object that will contain the rules that represent a set of permissions within a namespace, right? And then we have the role binding, which is the object that simply grants the permissions of a role to one or more users, right? So you have on the top image there, you have the role and a namespace level, and you have a role binding, and you have a group of users, right? So it's basically a set of permissions on a role, and role binding connects them, the users and the role together, right? Binding them together. And the same thing for the other objects is the cluster role and the cluster role binding. Basically, the main difference is that on the role object, it's the permissions are set on a namespace level, and on the cluster role, the permissions are on the cluster level, right? So they are more broad and more permissive, right? So you have to be very careful with that. And the cluster role binding works the same way as the role binding, but the permissions are on the cluster role for the set of users. The etcd is the main data storage location for your cluster, like we mentioned before. This means that all your cluster objects are saved here, right? So if someone has access to your etcd and permissions to edit objects there, they basically can change anything on your cluster. So they can modify stuff, and because Kubernetes keeps looking at etcd for the updated information that's there, to reflect that state on your cluster itself, right? So like which nodes are part of the cluster, which resources exist there, everything are saved here, and they're saved in plain text, right? So that's something that we're gonna discuss later. But we've seen over 2,600 exposed etcd services on Shodan this year. So be very careful, because the etcd also has an API that it can interact with, which is usually not exposed to the internet. But if someone's able, or like a malicious insider is able to interact with that API, he will be able to maybe alter things on etcd. So for etcd itself, the main things that you need to worry about is the security in transit, the encryption in transit, and the encryption at rest. The encryption in transit, it's set by default, and it's usually taken care for you when you create your cluster. So you can see that Kubernetes creates a certificate and a key file for your etcd. So all the communications between the etcd and the other components are encrypted. But the encryption at rest, the encryption of the object itself inside Kubernetes, are not done by default, right? So by default, as I said, they're stored in plain text, and you need to be very careful with that. So to encrypt those informations inside your etcd, you need to create an encryption configuration object and apply that to your etcd, and then restart it so that it can start encrypting that information. For example, secrets information that are sensitive information in your cluster, you should definitely encrypt that. So talking about network policies, right? Network policies is a object that can be created by the Kubernetes itself. So by default in Kubernetes, all pods can communicate with any other pod in your cluster. by default, and it's like a flat network, right? So even between different namespaces. So that's a big issue, right? So make sure you create a proper network policy for your cluster. Some things to think about is here. Does the front end pod really need to talk to the database pod, right? Or just the back end pod, right? So depending on the structure of your microservices in your application, you need to verify which pods really need to communicate to each other, and definitely apply the least privilege principle here, and only allow the pods that are required to communicate with each other to really do that, right? So what if an attacker can access the pods on your kube system namespace, right? Since it's a flat network, if I compromise a pod in one namespace, I'm able to communicate to the other pod that's on the kube system namespace, and that's a big issue. That's a big security issue here. So on AWS, for EKS, their managed services for Kubernetes, they have the network plugin that don't support network policies. So that's one other thing that you need to worry about. If your the network plugin, the CNI that you're using, like Calico, Weave, Flannel, or other CNIs, if they don't support the network policies, then even if you create an object, it's not going to work. So one thing that AWS did is that they released recently the security groups for pods. So you can use the common security groups objects that you usually do for use for your EC2 instances. You can use for specific pods on your cluster. So it's kind of a network policy there. And for the worker nodes, when talking about security as well, same thing applies here, right? So you have a few files, different files and different locations from the master node, but you need to be aware of and like alerted if any of those changes, right? So here are the recommended ownership and permissions according to the CIS benchmarks of those files. And you should monitor those and get alerted if any of those changes. On the kubelet side, right, we mentioned that the kubelet is the agent that runs on each node on your cluster. Even on the master node itself, there is a kubelet running there, even though it doesn't show on the architecture diagram. It needs a kubelet there to, Kubernetes needs that to run the pods that are running on your master node, right? So the etcd, API server, and stuff like that. So it makes sure that all the containers running in a pod, as we said before, all containers have to run in a pod. The pod is the smallest unit that you can have on Kubernetes. So for the Kubelet best practice here, the main security settings are restricting the Kubelet permissions and rotating the Kubelet certificates, right? So restricting the permissions can mitigate the attackers from reading your Kubelet credentials after they broke out of the container and are able to do other things in a cluster, right? So the credentials of the kubelet are stored in plain text on a specific directory. So if someone compromises one of your pods and are able to break out of that container, right, they can access that information and they can impersonate the kubelet to talk to the API server using the kubelet credentials. So you can check for that as well and restrict those permissions. For the pods itself, you have some security settings that are available there for you. The main ones are those three that we're going to mention here. The first one is the limiting resources, right? So you don't want your containers or pods using all the resources that you have available on your node. So you can restrict the CPU and memory usage, just like what you can do with the Docker containers, right? But in Kubernetes, you have an object that's called resource quota that you can create and apply that to specific pods to have them restricted with those specific limits and resources, right? Another thing that you can do is create and apply a security context, which is kind of a security settings that you can do for your pod. Some of those are listed here. For example, allow privilege escalation false, right? So you don't want your containers to be able to escalate privilege. and get more capabilities, right? Read-only root file system. So you should set that to true, because you don't want your root file system of your containers to be writable, right? So if someone can write there and then they can modify it, and that's an issue, excuse me, and runs as non-root. So I set to true because you don't want your pods or containers running as the root user, right? Because if someone compromises that, basically it's easier for them to break out of the container. The last thing that you have for the pods security settings is using the SecComp, AppArmor, or an SC Linux security features, which are the kernel, Linux kernel features there. The SecComp features process system calls. The AppArmor uses the program profiles to restrict the capabilities of individual programs. And the SC Linux applies some security labels to objects and evaluates all security relevant interactions via the security policy. So all those can be applied directly on the security context, right? Or you could use something like pod security policy, which is here the next thing we're going to talk about. And it's like an object that you have, and you have all those security settings, and you apply that to your cluster level, to your cluster, and it enforces those settings on the cluster level, right? So it works with an object, and it's also an admission controller that you have to enable on your Kube API server because it's not enabled by default. And so then you can apply that and make sure that all the pods that are deployed on your cluster, they must have those security settings. And lastly, but not least, the audit logs, right? So we mentioned that logs are very important. It helps you to troubleshooting and identify some security issues. The audit logs in Kubernetes, they are not enabled by default. So to enable them, you basically need two things. You need a log path and a policy file. And you set those on the Kube API server configuration, right? So the log path is basically where your file log is going to be stored. You can store locally on your master node, although that's not recommended. And your policy file is going to tell you like what is going to be logged, right? So what kind of data or what log level that you want on that cluster, right? So for the audit policy, you have four logging levels. You have the none, which doesn't log anything. You have the metadata, which is only logs request metadata, not the request or response body. You have the request audit logs, which logs the metadata and the request body, but not the response. And you have the request and response logging level, which logs the event metadata, the request and the response body. So you can see those are incremental, and also because of that, they're increasing in size as well because of your the amount of data that they store. So you should have that enabled on your cluster. The policy that's what it's going to be logged, that's up to you, but you should at least have some stuff that logs the request data, some request information there as well. On EKS, the audit logs are very easy to enable, right? So you can just go to your control plane, and there's a tab there called logging, and you just click a button, so like a switch, turn on switch to enable the logs, the audit logs. They have other logs as well there, the API server, authenticator, controller manager, and scheduler. None of those are enabled by default, so you should enable those. And once you do, all those logs go to CloudWatch, and you can see those logs there. So to summarize everything that we talked about here, I know it was kind of quick, but we have a short amount of time. So basically, remember the basics as well. So for your Kubernetes, make sure you update your environment version early and often, right? So Kubernetes releases new versions every 3 months, right? So there's a new version there, so make sure that you're up to date, your clusters are up to date as well, because not just new features are available, but bug fixes and other security settings are bundled into these new versions, right? So make sure you do that. Don't use your cluster admin for your daily work. So treat it like a root admin, right? So because anyone that has cluster admin permissions on your cluster can do basically anything and make it easy for them to break out of your cluster and access your nodes. If you can, if you're not bound to any legal policy or compliance requirements, you should use some managed services such as the AKS, EKS, or GKE, which is basically the managed services for Azure, AWS, and Google Cloud, respectively. And because they handle the control plane for you, so you don't have access to it, and you don't need to worry about the security settings there. So it's better. And usually some of them don't even charge you for the control plane. They only charge you for the worker nodes that you have, right? And also check out the CIS Kubernetes benchmark. Has a lot of information there about the best practices and security settings. It seems like a long document, but it's just a very detailed and with the commands on specific commands to check that if that setting is enabled and how to set that setting if it's not enabled, but it's easy to read. So, and before we finish, I just want to point out two great materials that you should look at if you're looking to just studying more Kubernetes security and learning and going to like a deep dive level. This is the Kubernetes threat matrix that was released by Microsoft earlier this year in April, right? So the Microsoft security team I think from Azure, they released this matrix based out of the MITRE ATT&CK framework. It's not an official matrix for the MITRE ATT&CK, but it's very helpful that shows you based on each tactics and techniques, which techniques are used, by the attackers and by criminals to compromise your cluster that can be used, right? It's not a complete, it has some missing techniques and missing step, but it's a great start for you to start understanding and protecting your cluster better. And to finalize, this is the GitHub project that I created, the awesome Kate security list. This is the link there on the slides. It's a free and open source project. Basically, it's just a bunch of links and information on videos, presentations, tools, and other repositories that I found while studying Kubernetes. So it has some information on basic Kubernetes and how it works. And then we go into deep dive into the security stuff, showing some tools and some great presentations of other speakers. So it's a great way to learn. So feel free to start and fork that project on GitHub. And if you have any other links or any other information that you'd like to add, you can easily submit a PR and I'll take a look at it. So that's it for today, guys. I hope you enjoyed this talk. And if you have any questions, feel free to ask them in the Q&A session later after this talk. Thank you.